And you have a situation like this. You have a regular polygon. They want you to find the area. Now, in geometry, they had different rules for these. I mean, and no matter what you do on this one, you're going to have to remember some geometric rules and things like that. For instance, first of all, what a regular polygon is. And a regular polygon is a polygon where all the sides have the same measurement and all the angles have the same measure. And along with that, you should also kind of know that, there's a formula for figuring out the sum of the angles of any polygon. In this case, it's a hexagon. So I should be able to figure out that each of those angles are the same and they all are 120 because they need the total 720 degrees. It was a formula n minus 2 times 180. So, Now, one way we could break this down is to split it into, again, two triangles and a rectangle. I mean, I could force, 90-degree angles here between those sides of 10. And form those 30, 30, 120-degree angles, And I can come up with the third side. I can come up with those side measurements because I would use the law of cosines to figure that out. So x is 10 times the square root of 3. And I can find the areas just by, for the two triangles by doing 1/2 10 times 10 does a sine of 120. Now that I have the sides of the triangles being 10 and 10 square root of 3, I can just multiply those together to get the area of the rectangle. And when I add that all together, I get 150 times the square root of 3 square inches, which is about 259.81 square inches. Another way of dealing with it, again, I still have to know some things about a regular polygon. I can also recognize that a regular polygon has a center, and it has a radius. A radius is always drawn from the center. For a polygon is drawn from the center to a vertex, like a corner point. And so I could draw these 6 radii, which are congruent. Each of those angles in the middle should be the same measurement, and they should total 360 degrees for a full circle, which means each angle is 60. And if I have an isosceles triangle with a vertex angle of 60 degrees, it means the other angles are 60 degrees as well, which kind of breaks up the 120s. So what I have are some equilateral triangles, 6 of them, namely, forming this regular hexagon. It's actually a hexagon. So I know each one of these sides is 10, so I have 6 triangles where the 3 angles are 60 degrees, the 3 sides are 10 inches. I could use the new formula for the area of a triangle, 1/2 10 times 10 times the sine of 60, get that area, and then multiply it by 6. And that would give me 150 times the square root of 3 square inches, which is the answer I had before, which is 259.81 square inches. So, there are methods, and when you deal with figures, sometimes, drawing auxiliary lines into them is needed to be done, but sometimes you have to look and see, okay, if I draw the auxiliary line this way, do I have enough information? And usually if I'm splitting it into triangles, and if I don't have at least 3 measurements in that triangle to use, or at least in one of the triangles I created, when I split a figure up into triangles, then I should consider drawing other auxiliary lines, or drawing them in different directions, or drawing it from different corners, or something like that. So, keep that in mind. If I draw auxiliary lines to form a bunch of triangles, and one of those triangles, at least one of those triangles does not have 3 known measurements as a result, kind of leads you to say, well, then, maybe this is not an auxiliary line I should be drawing. I should be drawing one that gives me more known information than unknown.